Okay, good question. Where does that 2 come from? I'm pretty sure you mean this 2, and I can see why you're confused. Okay, so I'm assuming you get this step. That's the product rule for the first derivative. So what I'll do is I'll show you maybe in one extra step so it'll be a little more clear. You have across this sum, this common factor. And this is pretty, for these problems, this is pretty common to have different powers, and you factor out the base of 11 minus t. So let me just do that step, and I'll factor out what I highlighted. So we go 11 minus t, and we always factor out the smallest power, and let's see what that leaves us with. So if I factored out to the negative 1/2, and this whole guy got factored out, it just leaves me with a t times a half times negative 1. So that's 1/2 t, make it negative. And then over here, if you factor out the negative 1 from this, you should get plus 11 minus t, all to the first power, right? Because if I multiply that by that, I get that. Okay, so what they did, because they don't want this 1/2 in these parentheses, so basically we want to combine like terms in here, right? So if I go another step, I got 11 minus t to the negative 1/2, and then I can just drop the parentheses because there's no operation here, so I end up with negative 1/2 t plus 11 minus t, and then in the end, this would be, sorry, I'll get you there. This would be negative 1/2. If we didn't do the factoring, they factored out a 1/2, and that's why you have a 2 here. So they've pulled out a 1/2 here. Maybe that would be a better way to explain it. But I'm just showing you how I can get the same answer. That would be negative 3/2 t plus 11 without factoring out a 1/2. So I guess at this point, this is the denominator, right? So that's equal to negative 3/2 t plus 11. And then down here, I would have this guy. That's the square root, what they have, square root of 11 minus t. And this is my answer, but I got a complex fraction, right? That's no good. I think they're just recognizing that up here when they factored out the 1/2, because then they can put the 2 in the bottom. So if you factor a 1/2 out of something that doesn't have a 1/2, then you get a 2, right? Because 1/2 times 2 would be 1. Or if you do it my way and you get here and you say, well, I don't like this complex fraction, so I got to multiply by 2 over 2. And then when you distribute that, 11 times 2 is 22, and then the 2's would cancel out, and you get a minus 3t, and then this 2 now is here, and that's another way to do it. But to answer your question, where did their 2 come from? If I'm at this step and I say, okay, I'm going to factor out this guy, which I did, but I'm also going to factor out the 1/2. So let's call that 1/2 11 minus t to the negative 1/2, and then let's see what we're left with. Well, if I factored this out and the 1/2 out, then this wouldn't be here, right? So it would still be, so it would just be a negative t. Okay, so that's this t right here. So we factored him out and him out and the negative 1. So it leaves with a negative t. And then the question is, what happens when you factor this thing out of this thing? Well, you'd still have that 11 minus t to the 1. But because we decided to pull out the 1/2, then you have to ask yourself, 1/2 times what would give you this with no coefficient? So you'd have to bring in a 2. Right, and that's a little smarter way to do the simplification than what I did over here, because you recognize that's a fraction, that's going to the denominator, and then this 2 can live in the denominator, and then the numerator won't have a fraction in it at all, like we had to deal with over here. Okay, so it's kind of like a minor algebra thing, but it's a little bit complicated, right? Which happens a lot in calculus. But either way, if hopefully that makes sense, either way you do it, you should end up here.